Right. Okay. Give me 1 second. Okay. Right. We start. First, can you confirm whether I'm audible? Am I loud and clear? So I'll also check from my end. Am I loud and clear? Okay, fine, right? Okay, right. We'll start. We'll start. Good evening, all. Good evening, all. So today, as we planned, we are going to start our S2A discussions, right? And as I explained in the classes also, main purpose of doing something like S2A discussion is because for you to do more question types, and get familiar with these question types more, right? So other than what we are doing in the paper classes, right? They are all model questions and new questions, right? And other than that, yeah, I'll be giving the main focus to past paper question types, right? So mainly to past paper question types. Main purpose behind this is covering the past papers from this end, from S2A discussions, while covering all model questions and new questions from our paper classes, right? Because at the end, you have to cover both ends, right? Now, not doing only the past papers is not going to, it is merely not going to be enough when you are sitting for the exam, right? That is one thing. Covering past papers is not just going to be enough, and doing new questions is also, right? Whole new questions is also not just going to be enough, right? So we have to cover both, right? Both of them. So that's why we plan to start S2A discussions, right? So when it comes to this discussion, today we are starting with mechanics. In mechanics, we are starting with linear motion, right? And if you haven't downloaded the Tute in the sense, I have put the questions there, right? If you haven't got the Tute, I have add the link to the description, right? Go to the video description and go there, and there's a link. Go there and you can download the Tute there, right? So if needed, I can put it to the live chat as well. I think it's already in the description, so you can find it from the description, right? And without spending much time, my plan is to directly jump into the discussion of questions. So you also can try the questions. You can do the questions with me, and this won't take much time as a class, right? Because I'm also planning to have the S2A sessions after all classes are finished in the day. So in this kind of a free time, I'm planning to have these SUA discussions, and my plan is to finish the discussion like in around 1.5 hours, right? Yeah, somewhere around 1.5 hours. I think it will be manageable. Questions will be manageable, right? Okay then. I hope you have downloaded the route now, right? Let me share my screen. Right. So you can see my screen, right? You can see my screen and my audio both, right? Can see both now? Okay. So do you see two videos? So let me check. I think now it will be fine. Let's see. Right. Okay, now it's fine now. Only one video, right? Okay. So let's jump into the discussion, right? Question one. And here in SUA discussions, we are not just going to cover MCQs, right? We'll be doing all question types. Today we are starting with MCQs, and after linear motion MCQs here, right? So if I feel like we need to practice more MCQs, I will do another day for linear motion MCQs, and then we'll be like moving with other types of questions as well. And in the first phase of the discussions, I'll be going it as, I mean, unit based or unit wise questions, and then my plan is to do mixed questions, because now we have kind of enough time before the exam. This is around 6.5 months before the exam, so therefore we have kind of enough time now. So let's use the time effectively and productively. All right, so let's move on. First one, right? An object is projected upwards with a velocity of 100 ms minus 1 from ground. If the air resistance is neglected, it will strike the ground in. It will strike the ground in, right? A projectile is projected upwards from ground, no? Projectile, right? Not a projectile motion. An object is projected upwards, right? Something like this. This object is projected upwards with 100 ms minus 1. So we all know that it is going to do a linear motion like this. So it will reach a certain height like this. It will reach a certain height and it returns back. Something like this, right? It will reach a certain height and returns back. So at once, we can apply S equals UD plus half AD squared upwards if you need to find the time. So in the class also we have discussed for both 26 and 27 students, right? Easiest way to find time in this kind of a question is applying S equals UD plus half AD squared upwards at once without finding times for 1/2, right? At once you can do this. Then total vertical displacement from start to end is 0, right? Total vertical displacement from start to end is 0, no? Right? Total vertical displacement from start to end is 0. U is, we are using the equation upwards, 100. T, since you are using the equation upwards, G is minus G, minus 10. T squared. So we know that half into minus 10 is minus 5. Take it to the other side. Then it becomes 5T squared. 5t squared equals 100t. 1t to t cancels, right? Then t equals 100 over 5, that is 20 seconds. That is 20 seconds. So answer is 4, right? 20 seconds, answer is 4, right? So you can take down if anything. You can take down if anything. Answer is 20 seconds. 20 seconds. And if any questions, you can put all your questions to the YouTube live chat, right? You can put all your questions to YouTube live chat so I can see, right? Okay, let's move on. Second one. Consider the following statements made about the motion of a particle. About the motion of a particle. Velocity of a particle cannot be, velocity of a particle cannot be reversed without changing the direction of acceleration. That is wrong. One example is the question that we just discussed. Because now, if you consider a vertical linear motion, something like this, a vertical linear motion. So at the topmost point, at this topmost point, you know that velocity becomes 0. At this topmost point, velocity becomes 0. But throughout the motion, gravitational acceleration acts vertically downwards. Right? Throughout the motion, gravitational acceleration acts vertically downwards. Then throughout the motion for the object, the only acceleration component acts on it is gravitational acceleration. So without changing the direction of this gravitational acceleration, direction of velocity has been changed, right? So which means first point is wrong. Velocity of a particle cannot be reversed without changing the direction of acceleration. Wrong. So without changing the direction of acceleration, it can be done. It can be done, right? Next one. When a particle is projected vertically downwards with a very large initial velocity, its acceleration will exceed the acceleration due to gravity. Another kind of a statement most of the students are messing up, right? When we are at the Earth's surface, right? On the Earth, gravitational acceleration cannot be changed, right? So even if you projected it with a higher velocity, right? Higher velocity, higher initial velocity, right? What happens is the impact is only with you, not the acceleration. Impact is only with you. Impact is only with you. G is a constant. G cannot be changed. G can be changed if and only if we go to another planet other than Earth, onto a surface of another planet other than Earth, right? When particle is projected vertically downwards with a very large initial velocity, then U changes. That's the only difference. U changes. Acceleration will exceed acceleration due to gravity. Wrong. It remains at G. See, when the acceleration of a particle is 0, when acceleration of a particle is 0, it must necessarily be at rest. At rest. No, Newton's first law. Newton's first law, right? So what he said goes, right? According to F equals ma, if A is 0, right? If A is 0, we know there are two possible states, right? So either it will be at rest, or it is moving with what? Uniform velocity. So therefore, it can be either at rest or moving with a uniform velocity. Statement 3 is also wrong, right? All ABC are false. All ABC are false, right? All ABC are false, right? All ABC are false. Newton's first law. Let's move on. Next. An object is dropped from a helicopter which is moving horizontally at a constant velocity of 45 ms minus 1, 180 meters above ground. Okay. If the object is detached from the helicopter, right, we call that helicopter as the parent body, right? Parent body. Then what happens is that object, sister object, or that is called the sub-object, immediately acquires the direction and magnitude of velocity of the parent body. Therefore, even though this object is dropped from the helicopter, right, so it travels 180 meters above ground, 180 meters above ground, this is not going to be released from rest, right? Since the helicopter is moving, immediately this gets a velocity of 45 ms minus 1. Immediately this one gets the velocity of 45 m is minus 1. So with that velocity, we know since gravitational acceleration is downwards and velocity is horizontal, it is going to do a projectile motion. It is going to do a projectile motion like this. That is going to do a projectile motion. So the question is time taken for object to reach ground. Then at once use S equals ut plus half at squared downwards. S from starting point to end point, vertical displacement is 180. Vertical displacement is 180 equals u, special point, u is 0 because this is a vertical velocity. This one here is a horizontal velocity, but my direction of application is vertical. So that is a perpendicular direction. Perpendicular vectors are neglected. So that is 0 plus half downwards plus d plus g t square. Right? Okay, then 180 equals half into 10 is 5, 5d squared. Then 180 over 5 is 36. 36 equals t squared. T equals 6. T equals 6. So that is 6 seconds. T equals 6. That is 6 seconds. Right? That is 6 seconds. That is 6 seconds. Right? So you can quickly take down your notes if you are taking down anything. So is there any short methods? For this one, no. This is the shortest. This is the shortest. Right. Question 4. So in question 4, there's a small typing error. Right? I will correct the typing error when we do the question. Right? There was a small typing error in question 4. Right? I will correct it when we do the question. Okay. Next. For the figure shows the velocity time graph for a particle which starts from rest and moves along x direction. According to this graph, right? According to this graph, A, the particle comes to rest only at time t equals t3. Right? Let's explain the behavior of the motion. See, let's explain the behavior of the motion. It is starting from here. Look at the screen. It's starting from here. Velocity 0. And from here to here, we know velocity increases, which means there is an acceleration. Then it has reached the maximum velocity at this point. It has reached the maximum velocity here. And then velocity decreases. Then this part is an acceleration. So this part is a deceleration. To initial direction. And at this point, its velocity becomes 0 again. Right? Its velocity becomes 0. But at the very next second, its velocity has been reversed. Negative, no? Negative means its velocity is reversed. Reverse velocity in the sense, at this point, the object has switched the direction. The object has switched directions. Right? The object has switched directions. Right? The object has switched directions. Right? And then from t2 to this point, again value of velocity increases, magnitude increases, which means this is an acceleration again to the opposite direction. Right? And here this is a deceleration again to the opposite direction. And you can clearly see at this point and this point, both of the points, it comes to a rest. And this first one is a momentarily rest. Right? This is a momentarily rest. For a moment, there is a momentarily rest. Right? For a moment, it comes to the rest. Momentarily rest. Right? And here also, here we don't know whether it is momentarily or it is a complete rest. That we don't know. And the statement is the particle comes to rest only at t equals t3. No? Wrong. It comes to rest at t2 and t3. It comes to rest at t2 and t3 both. It comes to rest at t2 and t3 both. B is the particle returns to its original position at time t equals t3. If you need to check the position, check its displacement. Right? If you need to check the position, check the displacement. Right? To show you the displacement, I'm going to erase this part. Right? See? Now, if this area is, see, this area represents displacement, right? Displacement S along the initial direction. This area represents, right? This area represents S along initial direction. Along initial direction. And this area here represents displacement along opposite direction. Right? If these two displacements are equal only, it reaches the initial point. Right? Since these two displacements are not equal, it doesn't reach the initial point. The particle returns to its original position. Wrong. Displacements are different. Right? Because initial direction is, let's assume the initial direction as horizontally rightwards, then opposite direction should be horizontally leftwards. If these two displacements are equal only, it returns back to the initial point. If they are not equal, that is somewhere else. Right? That is somewhere else. So that's a positive difference remaining, which means that is somewhere in the initial direction. Right? See, the particle accelerates only during the time interval 0 to t1. There are two accelerations. See, I explained in the first one. From here to here, this accelerates in the initial direction. Accelerates along initial direction. And at this part, see, this part is the part most of you are missing. At this part, also it accelerates along, right? Accelerates along opposite direction. Right? Now, when you are given this kind of a question, right, think about the direction separately, because direction gives you direction and the sign, right? Sign gives you the direction gives you the sign. And if you check the magnitude gives you what actually happens for that value, right? Therefore, both of them are accelerations. Directions are different, but both of them are accelerations. Velocity increases in both cases. Right? The particle accelerates only during time interval 0 to t1. Wrong. Right? Wrong. So all are false. That's why I told you there's a mistake. The mistake is here. You can correct this one as, you can correct this fifth statement as all ABC are false. Right? Correct this as all ABC are false. Right? And the answer is 5. Correct it as all ABC are false. Right? All ABC are false. Can you explain the motion from T1 to T2? T1 to T2, deceleration towards initial direction. Deceleration towards initial direction. Right. Next. Question 5. An object is dropped from a height h bounces back from the floor to a height h over 2. Which of the following velocity time graphs best represents the motion of the object? Right. So it's something like this. It is coming down from a height h. It is coming down from a height h, and it bounces back only up to height h over 2. It bounces back only up to a height h over 2. Then first point you should understand is there is a difference in displacements, right? Second displacement is half of the first displacement. Second displacement is only a half of the first displacement, right? Displacements are given by area of the curve, area of the VD curve, right? Displacement is area, no? Okay, and the other thing, even though your motion is downwards or upwards, doesn't matter always. Gravitational acceleration, direction of gravitational acceleration is downwards. Since direction of gravitational acceleration is downwards, acceleration is unchanged. Since acceleration is unchanged, gradient of graph is unchanged, right? Gradient of graph is unchanged, right? So therefore, if you have graphs with different gradients, all of them are wrong. 3 is wrong, different gradients, right? In 4, different gradients, wrong. In 5, 5 same gradients. Then I have 1, 2, and 5. Then check the areas. Initial area should be, right, twice as the final area, because when it comes back, it covers a distance h. When it goes up, it covers only a distance h over 2. Then initial area should be final area should be only half of the initial area, right? Then second one is also wrong because their areas are equal, these two. right? And in fifth one, this is not a half, this area is less than a half. So therefore, there is answer 1. Answer 1. Final area should be half of the initial area, and direction of velocity changes. When direction changes, it should be in the negative side, and gradient doesn't change, right? Gradient doesn't change because acceleration is unchanged, right? Those are the things you should check. Answer 1, right? So once you check those things one by one, so it comes without any hassle, without much hassle. Okay, next. 6. A bird is flying at a height of 40 meters with speed of 10 ms minus 1, drops a small fruit from mouth. If free fall is assumed, the speed of fruit just before it reaches the ground is. Okay. Now, again the same thing. This bird becomes the parent body, and the fruit that is released from the mouth of the bird is the sister body. Always the sister body acquires direction and magnitude of velocity of the parent body, right? And it is 40 meters above, something like this, from the ground, right? From the ground, this fruit is 40 meters above. The fruit is 40 meters above. 40 meters, right? 40 meters above. And direction and magnitude of the velocity of the parent body is 10 ms minus 1. So we know gravitational acceleration is g acting downwards. So it is going to do a projectile motion like this. It is going to do a projectile motion. And we know horizontal velocity component of projectile motion is constant. Then when it is reaching the ground also, this horizontal component should be same as 10 ms minus 1. Horizontal component should be same as 10 ms minus 1. But vertical component changes. So I'll assume this vertical component as y. I will assume this vertical component as y. Right? Let's assume this vertical component as y. To calculate this vertical component, right? Since we know distance, we can apply v squared equals u squared plus 2as, right? That's the easiest equation, no? V squared is y squared. U squared is 0 because we are using the equation vertically. Plus 2, g is 10, h is 40, right? It says y squared equals 800. Then y equals root 800. Just knowing y squared is also enough. Now here we have two velocities. We know actual velocity is the resultant of these two. That is in between. Resultant of these two. And that resultant can be determined as, we know resultant is equal to x squared plus y squared, resultant squared. Then r squared equals to x squared here is 10 squared, right? X squared here is 10 squared. And y squared here is, y is determined 800, right? 800. Then r squared equals 10 squared is 100 plus 800, which means r squared equals 900. R equals root 900. R equals root 900. That is 30, right? That is 30, which means it is reaching the ground with the velocity 30. It is reaching the ground with a velocity 30, right? Idea is resultant velocity is given by the resultant of two perpendicular vectors, right? Horizontal velocity component and vertical velocity component, right? Next, 7. Figure shows 5 displacement time curves for 5 different objects. 5 different objects. The object which has an acceleration in direction of its motion is given by, right? Displacement time, no? See, this is what you know from theory. Gradient of displacement time graph is velocity. Gradient of displacement time graph is velocity, right? If a system accelerates, this is the meaning, no? If a system accelerates, its velocity should increase over time. If it accelerates, its velocity should increase over time. If velocity increases, according to gradient of st should increase, no? Gradient of st should increase, right? Gradient of st should increase in that given direction, right? Now, these are the gradient types we have. We know all 5 gradient types here, right? And from these ones, if I forget about all the constant ones, the straight lines are constants, right? Then curves are they either increasing or decreasing ones. We know this gradient is a positively decreasing gradient, and this gradient is positively increasing gradient. So what we need was an increasing gradient. Then only increasing gradient given here is E. Very straightforward. Only increasing gradient given here is E. Right? Argument was, if you need to check about acceleration, right? Acceleration is an increase of velocity. But in a displacement time graph, velocity is given by gradient. Then if acceleration is there, if that is accelerated, velocity should increase. When velocity increases, gradient increases. Right? So increasing gradient is E. 8. The figure shows velocity time curves of three particles A, B, and C moving along a straight line. If at t equals 0, all the particles can be found together. All the particles can be found together. Right? All the particles can be found together at a certain point, which means all of them are at a certain point on the straight line. Then at t equals 10. Okay, at t equals 0, they are at the same point. At t equals 10, they are asking what is happening. Right now, to do these calculations, I'm going to extend this line. See, now if this line is extended, you can see these intersection points. Right? You can see these intersection points. Okay. Now, particles A and B meet again, B and C meet again. Okay, that is about a meeting, no? Meetings are checked using displacements, right? That is a very popular and a common idea we have discussed in our theory classes and paper classes also, right? Displacements are checked by using displacements. Then if you need to check whether they are meeting, you have to check the displacement. That's the idea here. If you need to check whether they are meeting again, check their displacements. Check their displacements. Right. Let's check the displacement of A first. We know displacement is given by this respective theory. Look at here. Displacement is given by area. Area of VT. Right. Displacement is given by area of VT. Area of VT. Right. Now, if you need to find the displacement of A, SA is area under curve A. Right. Area under curve A. That is 10 into 5. 10 into 5. 50 meters. 50 meters. 10 into 5, 50 meters. This area, no? This area. This is the area under curve A. Right? Area under curve A. If you need to check displacement of B, SB, get the area under curve of B. Right? Under curve of B, there is a triangle. There is a triangle. Then half into, right? Base of that triangle is 10. And perpendicular height is also 10. If needed, you can connect these ones and see. See? That is 10. Then into 10. That also gives 50 meters. That also gives 50 meters. Right? And to make sure, let's check C as well. Displacement of C. That's a trapezium. See? If you need to find the displacement of C is area under this trapezium. Under C. Area under this trapezium. Under C. Area under the trapezium. Then parallel sides are 10 plus 5 over 2 into perpendicular height is sorry, 10 plus 5 parallel sides are 10 plus 5 and perpendicular height is 10. Then these 2 to 10 cancels 5. 10 times 10 plus 5 is 15. 15 into 5 is 75. 75 meters. Right. Now we know all about these ones. Displacements of A and B are equal. Since displacements of A and B are equal, A and B are meeting again. For sure, A and B are meeting again. So particles A and B meet again is correct. Right? Other statements are wrong, only correct one is asked. No, B and C doesn't meet because C is ahead of them. C is ahead of both of them. Displacement of C at this time is 75. So C is the one which is at front. That is moving ahead all of them. So answer 1. Answer 1. Right? Not a big deal. Not a big deal. Right? So at so at T2, it goes back to starting point. So at T2, about which question you are asking? No, at T2 it doesn't go back to starting point. It is decelerating to the same direction. Decelerating to the same direction. Right? Decelerating towards the same initial direction. Right? It's switching its direction of velocity at that intersection point of x only. Right? Next. 9. Which of the following curves correctly represents the corresponding velocity time curve for the displacement time curve shown in the figure? Very straightforward, and it's a popular type, right? Again, the respective theory part is, we know gradient of ST graph is velocity, no? Gradient of ST is velocity. Then if you know the gradient, which means, right, if you know the gradient of graph, which means you know the velocity. That's it. Then check out these gradients. See, we know this gradient is a positive constant gradient. This gradient is negative constant gradient. And this gradient here is also negative constant. And this is a zero gradient. And this is a positive constant gradient again. These are the gradient types. Then what happens to gradient, right? This is the theory. What happens to gradient will be exactly what happens to velocity. So then first part, positive constant, right? Positive constant, and these divisions are given to you to check the values. Divisions are given to you to check the values to get an idea about the magnitude of the gradient, right? Because what happens to the gradient happens to velocity, right? Then in the first part, if you check it, it is 201. See, here this is 2 divisions. Just checking the magnitude, because gradient can be written as, we know, gradient can be written as delta y over delta x. Gradient can be written as delta y over delta x, right? Then this part, delta y is this, 2 divisions, and delta x is this, only 1 division. Then for that part, for this part, the acceleration is 2, right? So likewise, you can check it out. And for this part, deceleration is also 2, delta y over delta x, right? And for this part, that is same, angle is same, no? And for this part also, you can check using given values. That is delta y is 1 or something less than 1, something like that. So we can just get an idea. Having an idea is enough. Right? Then see, first one is positive constant. Second part is a negative constant. From 1 to somewhere just beyond 2, that is negative constant, right? Then first answer is wrong, not a constant. And fifth answer is wrong, because after 1 it should be negative. Right? And for sure we know values of these first two are same. See, values are same. Then it should be the same value in opposite directions. Right? That is only at 4, no? Then it should be 4. That is only at 4. It should be 4. Right? Now, if you know correct theories, these theories, so easily you can tackle these questions. Right. Next, which of the following graphs best represents the variation of velocity v with an velocity with time of an object being brought to rest by a constant resultant force? Okay, then get some idea about acceleration, right? Then if it is taken to rest, an object is taken to rest by a constant force, right? Then it has an initial velocity and finally its velocity will be 0, right? If it is taken to rest, we know that direction of force should definitely be opposite, and simply it should be a deceleration, because it is reaching a rest, right? It is coming to the rest. Since it is coming to a rest, that is a deceleration, not an acceleration, right? Keep that in mind when you apply F equals ma. Then when we use F equals ma this direction, minus F equals ma. Now from this also you can verify that it is a deceleration. Deceleration is F of m, right? And now to create a relationship between velocity and time, we can apply V equals u plus AD along this direction. V equals u plus AD, right? And final velocity of the object is 0, right? It is being brought to rest. Now with velocity we have to plot. Okay, then let's consider V as V. And U as say V dash, or U as U. u as u, plus a, but a is minus f of m t. See, v equals u minus f over mt. Okay, then from here identify the variables of the graph. Identify these variables. T is becoming the x variable because in all graphs t is x variable. Whatever it is as a product with x is called the gradient. Then that is minus gradient. And this constant is intercept c. And v is y. So what's the shape? Minus mx plus c. Minus mx plus c, that is a standard curve. Minus mx plus c is a standard curve. Minus mx plus c, answer 3. That's a standard curve. Minus mx plus 3. Right? Answer 3. Okay. Now we are halfway down. We are halfway down the discussion. Any questions? Any clarifications up to here? Or is it all clear up to this point? We are halfway through. Halfway through. Is there any more clarifications? Any clarifications needed up to this point? Or is it all clear up to this point? Quickly. So put a thumbs up at least. I mean, if that is clear, put a thumbs up. If not, you can raise your questions. Right? I'll give you like 1 minute for questions and we'll move on again. All clear. Good. Okay, let's move on. Let's move on. For 26 students, you are only 29 weeks out of the exam, right? And since today is Sunday, 29th week is also has come to the end now, right? So starting from tomorrow, it will be the 28th week before the exam. Utilize your time, right? Utilize your time effectively and productively, right? Utilize your time. Don't waste even a minute of time these days, right? Because each and every second you spend, each and every minute you spend with the with your things here, with our studies here, is going to pay back you with the result, right? So what you will do will get back. What you do here will get back to you. That's the nature, no? Right? Not just in studies. So anywhere and everywhere, what we do will be what you are getting in return. That's a fact. That's a fact. What we do will be what we are getting in return. So that happens anywhere and everywhere. So here also, it's same and it's valid. Same and valid. Right? So don't waste even a second, not a minute, even a second of time. Okay. Let's move on. 11. We did this question in the class, right? We did this question in the class. Right? I'll do it again, but you all know this. The distances traveled by an object falling freely from rest during first, second, and third seconds. They are in the ratio, right? Something like this. The object starts the motion from rest, right? An object starts the motion from rest. Q equals 0, right? And we know it travels downwards like this. It travels downwards. And let's say after first second, now initial point is here, t equals 0. After first second, this is here, t equals 1. After second, this is here, t equals 2. And after third second, this is here, t equals 3. Then distance traveled during the first second is this. Say S1. Distance traveled during the second is, let's use a different color. Right? Distance during the first second is this S1. Distance traveled during the second is this S2. Distance traveled during the third second is S3 here. Right. Then, see, first we can use an equation from, let's label these ones as A, B, C, D. Whoever is from A to B. Then at once, S equals UD plus half AD squared. So at once you can get S1. At once you can get S1. See, S1 equals U is 0, right? U is 0. Half G 10 T squared is 1 squared. then S1 equals, simplify this, 5 meters. S1 equals 5 meters. S1 equals 5 meters, right? Then without applying for the second, because initial velocity of the second is unknown. Initial velocity of the second is the final velocity of the first second. No need to find. I'm going to use the equation from all the way from A to C, right? All the way from A to C. See, from A to C, all the way from A to C. Then total displacement is SAC. SAC equals U is 0, half G. From A to C, 2 seconds are spent, 2 squared. But we know SAC can be written as S1 plus S2. S1 plus S2 equals 5 into 2 squared is 4. Right? S1 is 5. Then 5 plus S2 equals 20. S2 equals 15 meters. S2 equals 15 meters. Right? So these are ratio you should know. I mean, the ratio of distances covered if an object is falling under gravity. Right? Starting from this, that is a must know ratio. Right? But I am doing the calculation again. If there's anyone who couldn't remember, so you to recall it. Right? Otherwise, this is a ratio that you should know. This is a ratio that you should know. 15. Right? And for the third one, right? For the third one, let's use from A to D, all the way from A to D. From A to D downwards, right? Total displacement is S1 plus S2 plus S3 half G T squared is 3 squared. S1 is 5, S2 is 15 plus S3 equals, this is 5 into 9, 5 into 9, right? Let me do this here. Then 20 plus S3 equals 45. So S3 equals 25 meters. S3 equals 25 meters, right? Then the ratio we need is S1 to S2 to S3, right? Ratio we need is this. Ratio we need is this. Let me write somewhere here. Ratio is S1 to S2 to S3, right? S1 is 5, S2 is 15, S3 is 25. Divisible by 5, 1 to 3 to 5, right? 1 to 3 to 5. So keep this in mind. Keep this in mind. This is a ratio that you should know. This is a ratio that you should know, right? Because we have also proved, and just by the general knowledge and the common sense also, you should know this. 1 to 3 to 5. So answer is 5. 1 to 3 to 5. Answer is 5. Right? So this is the proof if anyone needs. This is the proof if anyone needs. Right? Something we have already discussed in the class. Something we have discussed in the class. Right? Okay, let's move on. Next. Okay, next. 12. When two objects A and B move with uniform speeds towards each other along a straight line, they get 5 meters closer to each other every second. If they move in the same direction along a straight line with the original speeds, they get 1 meter closer to each other every second. The speeds of A and B respectively. Okay. So there are basically two ways that you can do the question. Either you can use a relative velocity, or else without thinking about relative velocities, you can just think of the motion what actually happens on ground, right? You can think of the motion what actually happens on ground, something like this. Now let me explain this first using an example. Look at the screen. Say one object is moving with 5 ms minus 1, right? And this means per second this travels 5 meters, no? Per second this travels 5 meters. Say we have a second object here. This travels with 2 ms minus 1. The idea is this travels 2 meters. This travels 2 meters during 1 second, no? Travels 2 meters during 1 second. That's the idea. Then initially they were here and here. Now they are here and here. Then they have close to each other by the addition of these two, isn't it? They have get close to each other by the addition of these two, 7 meters. Right? So simply, I'm going to use that idea. And if they were moving into the same direction, right? For 1 second, this travels 5 meters. And for 1 second, the other one travels 2 meters. So then they are getting close to each other by the difference 3 meters. Then they are getting close to each other by the difference 3 meters, right? So let's use this idea, because if a velocity is known, velocity is ms minus 1, no? So that is the amount of meters that it travels during a second. That is the amount of meters it travels during a second, right? So let's approach the question that way. That is easier. That is easier. So let's approach the question that way, right? So I'll be erasing this and going to approach the question with this idea we got, right? Look at here. Look at here. So let's assume the speed of, what are the objects? A and B, right? So let's assume speed of A as VA, right? And the speed of B as VB. Then when they travel in opposite directions, right? At once I can argue as VA plus VB equals, they get closer to 5 meters closer. Then 5. VA plus VB equals 5. Equation 1. Second scenario is when they travel in opposite directions, right? Sorry, same directions with VA and VB, right? Then difference comes. VA minus VB equals, right? I'm using this idea from the previous one now. When they have opposite directions, addition comes. When they have same directions, difference comes. VA minus VB is 1. Equation 2. Right, that's it. Add these two. See, 1 plus 2. Add these two. 1 plus 2. Right? When you add 1 and 2, VB cancels. Then 2VA equals 6. VA comes. VA is 3ms minus 1. If VA is known from 1, see, from 1, VA is 3. 3 plus VB equals 5. So VB equals 2. 2ms minus 1. Then 3 and 2. 3 and 2. Answer 3. Right? Very easy. If you got that idea at once, if you got the idea, that's the exact idea you should have. That's the exact idea you should have. You have to have. Right? That's it. Right? Let's move on. 14. Displacement of a particle measured along x-axis with time t is shown in the figure. The magnitude of the velocity of the particle is largest when it travels from. Displacement time graph is given, no? So the respective theory is gradient of displacement time is velocity. Then higher the gradient, right? Higher the gradient, higher the velocity. Higher the gradient, higher the velocity. Check gradients, right? Magnitude of the velocity of the particle is largest when, right? Then answer is largest gradient. Answer is largest gradient. Divisions are given. Divisions are given. So you can check with these divisions. Let's check the first one. First one, how many divisions upwards? Delta y, because gradient is, writing again, gradient is delta y over delta x, right? So how many divisions upwards here? 1, 2, 3, 4, 5, 6, right? 6. And here 1, 2, 3, 4. Then for first part, 6 over 4. 6 over 4 is 3 over 2, right? 3 over 2. For the second one, you can check using this whole triangle. That is easier, no? Then for whole triangle, delta y is, that's the same gradient. That's why I'm checking the whole triangle. And this point is not an exact point. This point is not an exact point given. So therefore, check with the whole triangle. That is easier. Check with the whole triangle. Check with the whole triangle. Then 6 and 1, 2, 3. So this is 9 altogether. This is 9 altogether. And for this side, 1, 2, 3. This is 3, right? This is 3. Then this one is 9 over 3. That is 3. That is 3. This is 0. No need to check. That is 0. And this one here, this is also same, no? This is also same. Then 2 and 2, right? This is 2 over 2. 2 by 2. 1. Right? And this slope is definitely less than the other slopes, no? Then that is from B to C. 3. That is from B to C. Answer is 3. I mean, magnitude of the acceleration is 3. B to C. B to C. Right? Simple. So having thorough idea is very important. Having a thorough idea about the theory parts. Right? I'm recalling the surrounding theory parts as well with the questions. Right? Gradient and everything. Those are the basic theory parts. 14. In question 14, there was a small typing error. The error is this. First, let me correct the error. It should be corrected as this. T2 and T3 should be here. This is the mistake. This is the mistake. This is T3 and this is T4 and the last one should be T5. This is how it should be. Right? We can make that correction. This is how it should be. Right. Let's see. The displacement time curve of an object is shown in the figure. The corresponding velocity time curve is represented by, again, same theory, question with the same theory. Gradient of ST is velocity. Then knowing the gradient, you can get an idea about velocity. Right. Then see, first one, this gradient is positive and constant gradient. This is zero gradient. And this one here, throughout, this is a negative constant gradient, And this is a zero gradient again. And this is positive constant gradient again. Right? Positive constant gradient again. Okay, let's check. From 0 to T1, positive constant. So first one is already gone because that's not a constant. First answer is already gone. That's not a constant. First one should be positive constant. Right? In other answers, positive constants are there. Second part is 0. From T1 to T2, it should be 0. In all other answers, that's also there. Then from T2 to T3, it should be negative. From T2 to T3, it should be negative. T2 to T3, it's negative. Then second one is also wrong. T2 to T3, it's negative. Third one is also wrong. Right? And T2 to T3, it's negative. 4 is also wrong. Right? So for sure, answer is 5. T2 to T3 is negative. You can check the rest as well. And T3 to T4 is 0. Correct. T4 to T5, that's again positive. Right? So answer 5. Use correct theories. That's the thing. Use correct theories. Use proper theories. Use correct theories. Right? Next. 15. The graph shown represents the velocity time curve for an object. The corresponding displacement time curve is represented by, okay, that's a backward conversion. See, this is the first backward conversion in this set of questions. Same theory, but a backward conversion. Theory is gradient of ST is velocity. Now velocity is given. Then knowing the velocity, you can get the gradient. What happens to velocity will exactly be what is happening to the gradient of that graph. Then check the behavior of velocity, not the gradient, because what happens to velocity, look at the screen, what happens to velocity will be what is happening to gradient. Right? What happens to velocity will be what is happening to the gradient. Then check what is happening to velocity. This is called the behavior. This is called the behavior of velocity. Check the behavior of velocity, not the gradient. Check the behavior. This behavior is, this is positive, and value decreases. Right? Behavior is value decreases. Right? See, value decreases. Let me put it here again. Right. This is positive and this value decreases. And this side, this behavior is still positive, but the value increases. Then what happens to velocity will be happening to gradient there. Then this should be a positively decreasing gradient. Right? It should be a positively decreasing gradient. Gradient of ST. Right? This should be a positively increasing gradient. Positively decreasing gradients are we know these shapes from linear motion. Positively decreasing. Positively decreasing shape is this. This is the shape. This is the shape. This is the shape. Positively decreasing. And positively increasing. This is the shape. See? Positively increasing. This is the shape. Right? Then it should be a combination of these two. Positively decreasing and positively increasing. Answer 1. Positively decreasing and positively increasing. Answer 1. Right? Very easy. Very easy. Only thing is you should know the theory. You should know the theory. Right? Theory is playing a role. Theories are playing a role. Next. 16. The graph shown in the figure represents the velocity time curve for an object. The corresponding displacement time curve is best represented by. Right? Very much same. Very much same. Very much same. Same thing. Again, gradient of ST is velocity. Now knowing the velocity, you can get the gradient. Check this velocity again. This is a positive velocity, but it decreases. And this is a negative velocity, but magnitude increases. Right? Checking on two things, sign and magnitude. Sign and magnitude. For the first one, sign is positive and magnitude decreases. For the second half, sign is negative and magnitude increases. Then first half should be positively decreasing gradient, something like this. Second half should be a negatively increasing gradient, something like this. Negatively increasing. Then answer 2. See how easy the questions are. Right? See how easy the questions are. Right? Questions are easy. Questions are easy. Questions are easy when you know the correct theories, when you know the exact theories. Right? Otherwise, without knowing the theory, you might feel like it's too hard. It is true. Right? Then using these questions, try to recall the theories. Right? That's the purpose, whole purpose behind S2A discussions. Recalling theories, making you more comfortable with the questions. Right? And these are the questions already appeared as past papers. Right? Then you know the value of these questions and the patterns and the expected level from these questions. Right? You know the expected level. This is the expected level. Right? Let's move on. 17. In which of the velocity time graph shown below would the average velocity over the entire period between T1 and T2 be equal to the average of the two velocities at the ends A and B of the interval? Now, first, you have to understand what is asked here. The question is asked in kind of a different manner. Below, would the average velocity over the entire period? Average velocity. What is the equation of average velocity? That we have discussed in the class. Equation of average velocity. Average velocity equals total displacement, right? If you need velocity, total displacement. If you need average speed, that is total distance, total displacement over total time, right? This is the equation, right? Make a theory. This is a theory part. Average velocity is total displacement over total time. Average velocity is total displacement over total time, right? Then, you know, total displacement can be found using area under the curve, no? Right. So before finding the area, let's see what is given in the other part of the question. Entire period between T1 and T2 is equal to the average of the two velocities at the ends. Let's assume two velocities at the ends are VA and VB. Then average of the two ends should be VA plus VB over 2. No? Average of the two ends should be VA plus VB over 2. If the velocities at endpoints are VA and VB, average of VA and VB should be VA plus VB over 2. Right? A simple idea. Then average of these two should be VA plus VB over 2. It should be VA plus VB over 2. Right? VA plus VB over 2. Then, if this area is equal to this value in any of the case here, it should be a correct match, no? It should be a correct match for the given scenario. It should be a correct match for the given scenario. So therefore, now since there's a 2 is coming, right? My focus is mostly towards either trapeziums or triangles, because when we write triangles and trapeziums, we know 2 comes, 2 is involved, right? So let's first check out with the trapezium here. There are no single triangles. Fourth one is 2 triangles. Third one is also 2 trapeziums, right? Fourth one again no triangles. That is actually 2 trapeziums. Then let's check out with the fifth one. Then area under this curve. Area under this curve, right? Area under this curve. Area under this curve can be written as total displacement. Total displacement is area under this curve, no? Then area under that curve is area of trapezium. Area of trapezium is addition of 2 parallel sides, VA plus VB, because this side is VB and height here is VA. VA plus VB over 2, right? Into perpendicular distance T2 minus T1, right? Perpendicular distance T2 minus T1 over total time. I'm applying this in the equation. Then this whole thing over total time. Total time is also T2 minus T1. No? See what happens? These two cancels. These two cancels. And only this thing remains. Right? This is the average between two ends. So which means the only possible answer here is answer 5. Only possible answer here is answer 5. Only possible answer here is answer 5. Right? That's a good question. If you understood, I mean, that's a tricky question. Right? So rather than it saying it's good, it's a tricky one. It's a tricky one. It's a tricky one. First thing you have to understand what is asked. Average between two ends, two terminals, should be equivalent to the average velocity throughout the period. Applying the equation of average velocity. Right? Next. A particle P moving with uniform velocity of 4 ms minus 1 along x-axis passes origin over time t equals 0. Since it is given with respect to x-axis and y-axis, let me draw this x and y. Then origin is here, right? So what about the first particle now? A particle A, right? A particle A, right? Particle A moving along x-axis with 4 ms minus 1. 4 ms minus 1 passes the origin at t equals 0. Then this is t equals 0. Passes the origin at t equals 0. And particle Q, a particle P, right? Not A, it is particle P. Particle P. And second particle Q. See, second particle Q. There's a second particle here, particle Q. And it has a velocity 5 ms minus 1. 5 ms minus 1 passes origin at t equals 1. This passes origin at t equals 1. Okay. Then particle Q will reach particle P when they have traveled a distance of. Reaching each other means they are meeting. So the question is put under the bucket of meeting questions. Right? This is put under the bucket of meeting questions. That's a meeting question. Put under the bucket of meeting questions. Then let's assume somewhere here they are meeting each other. Then Q should travel from here to here, from t equals that point to t equals t. Let's assume they are meeting time as t equals t, and the other one should travel from here to here, right? If they are meeting again, and they should be at the same point at the same time. Then total displacement covered by this one is from here to here. That is, let's say SP. Displacement covered by P is SP. Right? Displacement covered by P. Displacement covered by P, SP. And displacement covered by Q from here to here, let's say SQ. Right? When these displacements are equal, they are going to meet each other. When these displacements are equal, they are going to meet each other. Right? Then apply S equals UT. There's no acceleration, no? Then what happens is when you try to apply S equals UT plus half AT squared, this acceleration is 0. There's no acceleration. Since there's no acceleration, this whole part becomes 0. Then using S equals UT is enough. Right? Use this equation for these two separately. Then for SP, for P, SP equals U is 4. Its moving time is from T equals 0 to T equals T. Then time difference is final minus initial. T minus 0 is T, 40. Right? So SP equals 40. And for B, sorry, for P and Q, for Q, SQ equals, its speed is 5. And time is from T equals 1 to T equals T. Final minus initial, T minus 1. Then time difference is T minus 1. T minus 1. So SP and SQ are known. SP and SQ are known. Then when these two are equal, we know they meet each other. Then my argument is at the meeting point, SP equals SQ. At the meeting point, SP equals SQ. SP is 40 equals SQ 5 times T minus 1. Simplify this. 40 equals 5T minus 5. Take this 5 to the other side, left side. Then 5T minus 40 is T. That's it. T equals 5 seconds. So they meet after 5 seconds. The question is, particle Q will reach particle P when they have traveled a distance from the origin. So distance from the origin is SP, no? Speaking SP or SQ are both are same. Both the equations will satisfy, right? Using SP will be easy, right? Since I can just plug T without minus T minus 1. Otherwise, there's nothing like one is easy and the other one is difficult. Both the equations are very simple equations, no? So I'll be using this from SP, right? That is 4 into T is 5, 20 meters. Then they are 20 meters from the origin. 20 meters from the origin. See? 20 meters from the origin. Right? So use your known theories like wisely. We know if it is a meeting, from our theories, we know if it is a meeting, their displacement should be equal. And always, for any kind of a meeting question, any type of a meeting question, always argument is based on displacements. Right? So that is based on displacements. That's it. Next, 19. Right. Okay, this is a good one. 19. This is a good one. Okay, see, a person A standing on a trolley, moving with a constant speed V on a straight horizontal track, drops an object as shown in the figure. Right? Drops an object, and the system is moving. Right? Again, that's a parent body and a sister body. Now this parent body is moving with the velocity V. This moves with the velocity V. If it moves with the velocity V, this object which is released from here also will get the same velocity V. It will also get the same velocity V. Right? Drops an object as shown in the figure. B is an observer. It should be an observer, not if not name, correct this as an. B is an observer standing on ground. If the air resistance is negligible, the paths of the objects as observed by A and B are. Right. Now, see, look at the board. No, sorry, look at the screen, not the board. Look at the screen. Now, even though this one is dropped, right? This trolley along with this person travels to the right with same velocity V, no? It travels to the right with same velocity V. And this object, this is dropped, has got the same velocity V, right? Which means during the same time, they travel the same distance because their horizontal velocities are equal, right? V meters per second. During each second, they travel the same distance. If they travel the same distance, this person, who is that A? This person A won't notice any vertical difference, right? Not the vertical, sorry, horizontal. Won't notice any horizontal difference between these two because this distance will remain constant. Because both of them are moving the same velocity, right? Same distance during same time. So therefore, what he will observe is a straight line, relative motion. Because when the trolley travels V meters per 1 second, that dropped object has also traveled V meters for 1 second. then with respect to A, that is at the same point. So what he sees is that is only going down, but he don't see any horizontal movement. He don't see any horizontal movement. He sees only the vertical movement, right? So therefore, for A, 4 and 5 are wrong. A will see only a vertical movement. A will see only a vertical movement. Only a vertical movement, right? Then for B is on ground. B is on ground. B is on ground. Then this has a velocity. This has a velocity V. And with respect to the ground, we know B is on ground. Actual motion of this one is a projection. Actual motion is the motion with respect to ground. If this person is on the ground, that person will see the actual projection. That person will see the actual projection like this. Since the velocity is to the right, the direction of projection is to the right. So that person will see the actual projection. Then now it is very straightforward. 2. Answer is 2. Answer is 2. Got it? This won't see the projection. A don't see the projection because he is also moving along with the dropped object. A is also moving along with the dropped object. So therefore, no horizontal movement is seen. No horizontal movement is seen by A. No horizontal movement is seen by A. No horizontal movement is seen by A. Right? That's the thing. No horizontal movement is seen by A. Right? Next. A stone is thrown at a certain angle with the horizontal in the direction shown in the arrow. If the air resistance is ignored, which of the following velocity time graphs best represents the variation of Vx with t and Vy with t? And one small mistake here, this should be t with Vy. This should be t with Vy. Right? Right? Others are correct. Other answers are correct. T with Vx and t with Vy. Right. Now, if it is projected at a certain angle, if the object is projected at a certain angle, right, we all know that it is going to do a projectile motion. It is going to do a projectile motion like this. It is going to do a projectile motion, right? And one of the main theories that we discuss in a projectile motion is, right, horizontal velocity component of projectile motion remains unchanged. Horizontal velocity component of a projectile motion, if this is u, this horizontal velocity component of projectile motion is unchanged because only acceleration this acts throughout the motion is acceleration due to gravity. Acceleration due to gravity is always perpendicular to this velocity. Always perpendicular to this velocity. Since that is perpendicular, this velocity is unharmed. This velocity is not impacted, unimpacted, that is unharmed. Right? So therefore, this remains constant. This remains constant throughout the motion. This remains constant throughout the motion. Right? Horizontal component. Then there is one thing, there is a one main argument you have. Then this is the possible graph. This is the possible graph for horizontal component of Vx. This is the possible graph for horizontal component. See? This is the possible graph for horizontal component. This is the possible graph for horizontal component. This is a possible graph for horizontal component. About vertical component, we know vertical component starts here, right, as u sine theta. U sine theta. And at the topmost point of the projection, vertical velocity component becomes 0. And it is switched after the topmost point, and here it returns back to the ground. We have proved this with the same velocity that is projected upwards. With the same velocity that is projected upwards. Then from here to here, this velocity decreases. This is in a decreasing trend like this. This velocity decreases. And from here to here, this velocity increases like this. Right? Increasing and decreasing. But throughout, acceleration of the motion is only g. Acceleration of the motion is only g. Then acceleration should be constant. Acceleration should be constant. But direction changes. Acceleration is constant, but direction changes. Then this should be Vy. Starting from the initial value, reaching the topmost point and switching the directions. Still the acceleration is same because gradient is same. Then Vy is 3. So answers are 2 and 3. Answer 1. 2 and 3. Answer 1. Right. Okay. Use your arguments, use the arguments, right? Use your arguments, use your arguments. Right. Then, yeah, we have come to the end of all the questions I planned for today. Right, 20 MCQs. Now we have discussed 20 MCQs within like 1 hour and 20 minutes, 1 hour and 20 minutes of time. Right. So likewise, as I told you at the beginning also, when it comes to S2A discussions, they won't take much time. Right. I'm planning these discussions to like 1.5 hours. Maximum it will take like 2 hours. Right. Because I will be also doing this after all classes when I got back home. Right. And the whole purpose is giving you an advantage from this, right? And all the S2A discussions will be happening as YouTube live sessions, only as YouTube live sessions, right? So anyone can join and get the advantage, right? Then right, okay, then yeah, any questions about the 20 MCQs we discussed today? Any questions about the 20 MCQs we discussed today? Any questions? Anything to clarify? Anything to clarify? Any questions? Or are you all clear? Or are you all clear? Huh? Any questions? Or are you all clear? How about you? Any questions? Or are you all clear? Is it clear enough? Right. So if no questions, we can wind up. Right. If no questions, we can wind up. Yeah. Listen. Next week also, right? Listen. Next week also, we'll be having this S2A discussion at the same time, right? At 8, right? At 8, and if there are any changes, I will inform you all the things via channels, Telegram and WhatsApp channels. So if you are not joined into the WhatsApp and Telegram channels, you can join and stay connected, right? And all the updates, right? All the updates will be given via channels, right? All the updates will be given via channels, right? Okay. And for now, the time for the next discussion is also next Sunday at 8 p.m. Right? Next Sunday at 8 p.m. And to get these questions, if you don't have the questions, to get these questions, I'll be using the Telegram channel, right? I'll be using the Telegram channel because the thing is for WhatsApp channels, files cannot be uploaded. So therefore, for the PDF, I'll be using the Telegram channel, right? So likewise, as today, I will put the link in the description of the video. You can go there and download the Tute from Telegram as well, right? All right. The ones who joined today, now if you got something from the discussion, I'm just asking about because this is the first day about this. If you got something out of the discussion and if you feel like whether it's good or bad, I mean any feedback that you feel, if you feel like there are some points to be improved, right? Or if you feel like there are some things to be like rectified or anything like that. So either you can drop me a private message or simply you can add a comment to this YouTube video, right? Now, once this live is ended, this will be saved on YouTube as a video. No? So you can add a comment there, then everyone else can also see whether it was useful or not. And my plan is to continue this discussion up until your A levels 26, right? So we got around 6.5 months. Then for all 6.5 months, we'll be having the discussion, and plan is to have a weekly discussion, right? Weekly discussion. Now for now, it's going to be on Sundays. If any changes, we'll let you know through the channels, right? Okay then. Since we have come to the end of the discussion, we'll wind up, right? We'll wind up. Then let's see you again with the next S2A discussion, right? Okay then, that's the end. Good night and goodbye. See you all in the classes or other S2A discussions. Okay then, goodbye.